Welcome to the Oxygen Alliance YouTube channel, where we bring you videos on installation, maintenance, and various trainings on oxygen equipment and devices. If you have comments and or questions, drop them in the comment section below or write to us info@oxygenalliance.org. Remember to like our videos, subscribe to our channel, and hit the notification bell.
Hello and welcome to the Oxygen Alliance YouTube channel. My name is Victor Mzembe, a biomedical engineer for the Oxygen Alliance. Today, we'll tear down an AirSep New Life Intensity Oxygen Concentrator. The AirSep oxygen concentrators normally operate at voltages ranging from 220 to 240 volts AC and at a frequency of 50 Hz. For this oxygen concentrator, it operates on 230 volts AC at a frequency of 50 Hz. It has a capacity of 10 liters per minute and can deliver up to 95.6% oxygen purity at flow rates ranging from 2 to 10 liters per minute. Now, let us look at the external parts of the unit. So firstly, we have a power button. This button is used to start and stop the operation of the unit. Over here, we have a circuit breaker reset button. The unit has a circuit breaker which trips whenever there is an overload. The button is used to reset the breaker once the fault has been corrected. Over here, we have the digital hour meter. So this is used to record the number of hours for which the unit has been in operation. And over here, we have a flow meter. So the flow meter is used to indicate the rate at which oxygen is being delivered to the patient. And here we have the flow meter adjustment knob. So this is used to regulate the oxygen flow to the patient. Take note that some oxygen concentrator models can have two flow meters, while this one only has a single flow meter. Over here we have the oxygen outlet port. So this is where you connect the humidifier bottle or a face mask, or you can also connect a nasal cannula. Lastly, on the front side, we have three indicators. The top indicator is for oxygen purity. It turns yellow when the machine is just switched on. Once the oxygen concentration has stabilized, it then turns green. If the purity is below 82%, which is the recommended level, the indicator turns red and an alarm will sound. On the middle, we have the power indicator. This indicator turns green when the unit is switched on. Lastly, on the bottom, we have the service indicator. This indicator turns red when there is a malfunction within the unit. For example, when there is flow obstruction, a high output pressure, low output pressure, or compressor failure. On the back side of the machine, we have the gross particle filter. So this is used to remove dust and other large particles present in air before it enters the unit. And for this machine, an automatic voltage switcher has been connected. It switches off the machine once the mains power goes outside the preset acceptable limits. It automatically switches on the unit once the mains power returns to normal. Now, I will open the unit and take you through its internal components. And to do this, I will use a flathead screwdriver. So here we have the cabinet fan. The cabinet fan draws in ambient air, which is used to cool the internal components of the unit. The air then exits through the exhaust, which is located at the bottom of the unit. Over here we have four solenoid valves. The top two are the feed valves. So these valves allow air to flow into each of the two seal beds. The bottom two are the waste valves. These valves are used to purge nitrogen. So over here, we have another solenoid valve. So this is actually the equalization valve. This valve facilitates the pressurization of sieve bed as well as nitrogen purging during the depressurizing cycle. So this valve also allows part of the oxygen produced in the active bed to enter the other sieve bed, thereby reducing energy requirements and increasing efficiency. The oxygen concentrator has 3 printed circuit boards. On the bottom, we have the fan control board. This board controls the operation of the fan and provides power to the fan. It has a step-down transformer which is used to lower down the voltage suitable for fan operation. And over here we have the oxygen monitor circuit board. So there is an oxygen monitor on the board which monitors the level of oxygen concentration produced by the unit. Lastly, at the top we have the main control board. This board is used to control the opening and closing of the solenoid valves. It also controls the operation of all electrical and electronic components in the unit, such as the fan and the other control boards. The board has an AC input and a DC output. So on the left side, we have the AC input, and on the right side, we have the DC output. And this is where power is tapped, going to the buzzer, the indicator lights, and other components that uses DC voltage. Here we have 2 sieve beds. These sieve beds are used in the oxygen generation. They contain zeolite, which absorbs nitrogen, hence allowing oxygen to be concentrated. Here we have the pressure regulator. The pressure regulator is calibrated at 20 psi. It ensures that oxygen is delivered at a constant pressure of 20 psi. Now, I will show you how to remove the oxygen monitor circuit board. So this board is held in place by 2 screws located at the bottom. So one screw is on this side and the other screw is on that side. But before loosening the screws, I will first disconnect the cable that brings power to the board. So then after that, I will loosen the 2 screws using a Phillips head screwdriver. This is the oxygen monitor circuit board, and here is the oxygen monitor. The oxygen monitor has 2 connection ports. This port is for the oxygen inlet and it is connected to the inlet or the flow meter, while this port is for the oxygen outlet. So it connects the tubing that goes to the oxygen outlet. On this side, we have different parts that you can see after you remove the side cover. The first one is the buzzer. This is actually what produces sound whenever there is an alarm. And over here, as mentioned earlier, is the digital hour meter. Here is the circuit breaker. And over here is the power button. And lastly, on this side we have the cable connector. For us to access the other internal components, we will have to remove the front covers of the unit. So I will remove the bottom cover. The top cover has many connections on it. There is the power switch, the circuit breaker reset button, the digital hour meter, and the flow meter. So we'll have to disconnect all the connections to the flow meter, the switches, and the hour meter. To remove the top cover, I will first disconnect all the cables that are going to the power switch, the circuit breaker, and the hour meter. Firstly, I will disconnect this cable which brings live power to the circuit breaker. After that, I also disconnect this power cable which is connected to the switch. And then I will disconnect this power cable which goes to the hour meter. The next, I will disconnect this cable connector. So this connector has one neutral cable going to the hour meter and the other one going to the fan. So after disconnecting the power cables, I can now go ahead and disconnect the tubings. To disconnect this tubing, which goes to the flow meter inlet, I will use a cutter to cut the cable tie. Then next, I will disconnect the tubing that goes to the oxygen outlet port. You can note that the board is mounted on the top cover. So first you have to disconnect the board. And on the board we have the pressure transducer which is connected using this tube. So first you have to disconnect this tube. Now I will pull out the board from the pins holding it in place. Moving forward, you will need to loosen the two screws at the top. So to do that, I will use a star-head screwdriver. So now you can remove the top cover. And now the top cover has been removed. On the front side, we have the air compressor. This air compressor is of the Thomas brand 2660 series. It is there to increase the air pressure before pushing it into the seal beds for oxygen generation. The stator winding of this compressor has a thermostat. The thermostat offers thermal protection to the compressor in cases of high temperatures. This compressor has a pressure rating of 40 psi at a flow of 113.1 liters per minute. The compressor has a pressure relief valve fitted on it. The pressure relief valve is preset at 45 psi. Whenever there is an air pressure of greater than 45 psi in the air compressor, the relief valve will produce a popping sound. There is also a heat exchanger connecting the air compressor and the solenoid valve. This heat exchanger is used to reduce the temperature of the compressed air by dissipating heat. Over here we have the intake hose. So this one is actually the one which connects the compressor to the intake muffler, which I will show you in a moment. And it is used to bringing air into the compressor. And here we have the start run capacitor. So this capacitor is used to start the compressor. It is a 12.5 microfarads capacitor with a voltage rating of 450 volts AC at a frequency of 50 to 60 Hz. Now, I'll show you how to remove the air compressor so that you can access the intake muffler. So, to do this, you can see that there are 2 screws at the bottom. So I will have to loosen these 2 screws, and also there is a nut, so I also have to loosen this nut as well. To loosen the 2 screws, I will use a flathead screwdriver. To loosen this nut, I will use spanner number 16. Now you have to remove the base of the compressor, and to do this, I will use a flathead screwdriver and I will insert it to the bottom of the shock absorbers. But before doing that, you first have to remove the capacitor. Having looked at the parts of this oxygen concentrator, now let us look at its electrical system. As mentioned earlier, this unit operates on 230 volts AC. The 230 volts AC is supplied using this power cord. These cables here, these ones, bring power to the 4 solenoid valves. So over here we have this one, which is the live cable, and this one, the blue one, the neutral cable. And the same on the over here we have this one, which is the live cable, and the yellow one for the neutral. And similarly on the other side we have this one, which is the neutral, and this one, which is the live. And lastly, this one, which is the live, and this one, which is neutral. Over here we have the fan control board. It receives 230 volts AC and converts it to DC. The DC output is used to power the fan. So these are the 2 cables that are used to supply power to the fan. The red one is the positive and the black one is the negative. As mentioned earlier, this oxygen concentrator operates on 230 volts AC. The 230 volts is supplied using this power cord. So the cord has 2 cables. The brown one is the live cable and the blue one is the neutral cable. This neutral cable is connected on this side of the cable connector where all neutral cables are connected, and it provides a return path for current. This live cable is connected on the circuit breaker right here. So from the circuit breaker, power is then tapped through this cable going to the power switch. And from the power switch, we have this cable here that is connected directly on the live connection part of the cable connector. And this is used to distribute power to the other components. The power switch also has this plug cable. This cable is used to transfer DC output from the main control port to the switch. Over here is the digital hour meter. The digital hour meter is connected in parallel with the live cable. And The power cables for this digital hour meter are these two. So the black one is for the live cable and the white one for the neutral cable. Over here you can see two cables, the white one being the neutral and the black one being the live. These cables are for the fan control board. So the fan control board is connected in parallel with the live cable. This ensures that the board also receives 230 volts AC. We also have two cables here. So there is the black one and the white one. So this one is the neutral and provides a return path for current, and this one is the live. This live cable brings 230 volts AC to the main control board. So these two cables, this brown one and this blue one, goes to the compressor. So this brown one is the live and the blue one is the neutral, and they are actually used to power the compressor. On this side, on the DC output, we have 3 connection points. The connection point over here is for the buzzer. It is actually used to supply DC to the buzzer. On the middle here is where we connect the cable supplying power to the 3 indicator lights. And lastly, this connection point here is for the oxygen monitor circuit board. So it is used to power the oxygen monitor circuit board. On this side, we have a connection point for the 5 solenoid valves. So this is actually used to power the solenoid valves. And this cable is the one that brings power to the equalization valve, which is also a solenoid valve. As mentioned earlier, these 2 cables are used to power the compressor. The blue one is the neutral cable and the brown one is the live cable. So the live cable is connected in series with the thermal switch. Over here we have the capacitor. This capacitor is also connected in parallel with the live cable. So it also receives 230 volts AC. And that concludes the electrical system of this oxygen concentrator. Now, let us look at the pneumatic system of this oxygen concentrator. Air enters the unit through the gross particle filter, which filters out dust and other large particles. After that, air passes through the fine particle intake filter. So this one further removes impurities and small particles from air before it proceeds to the compressor. From the fine particle intake filter, air then passes to the intake muffler. From the intake muffler, air passes through the intake hose to the compressor. So the compressor then raises the air pressure up to 40 psi. This compressor is connected to the 4 solenoid valves, which consist of 2 feed valves and 2 waste valves. From the compressor, air passes to the solenoid valves. So this time around, it is the 2 feed valves that are in operation. These 2 feed valves control the flow of air from the compressor to the sieve beds. Once air is in the sieve bed, nitrogen is separated while oxygen is concentrated. Part of the oxygen produced in the pressurized bed is directed to the depressurized bed, and this helps in the purging of nitrogen in the depressurized sieve bed. From the sieve beds, oxygen passes to the accumulator tank or the product tank. So oxygen passes through this tubing to the accumulator tank. This check valve and also another one on the other bed prevents the backflow of oxygen as it flows to the product tank. From the product tank, oxygen passes through the pressure regulator. This regulator ensures that oxygen is delivered at a constant pressure of 20 psi. And from the pressure regulator, oxygen goes to the inlet or the flow meter and then to the oxygen monitor, from where it is connected to the oxygen outlet port. And over here, we also have another tube that is connected to the pressure transducer, which is on the main control board. And that concludes the pneumatic system of this oxygen concentrator. Now I will reassemble the oxygen concentrator. Firstly, I will replace the air compressor. The alarm systems associated with this oxygen concentrator are similar to those associated with the DeVilbiss 1025 oxygen concentrator. We have already made a teardown video of the DeVilbiss 1025 oxygen concentrator. If you need to know these alarms, there is a link in the description below. And that is all we had for you today. Don't forget to like, share, and subscribe to our YouTube channel. Bye.